Welcome back. Today we're going to look at free body diagrams. A free body diagram is a picture that represents an object along with the forces acting on the object. And just right up here, just want to let you know, here is where you can get these notes at http://db.tt/E lowercase n 5sy 5 capital E capital F. A free body diagram will show these types of forces: weight, the normal force, and tension. These are the big three. In other words, these are the main ones you'll see in most of your free body diagrams. Two other forces you might see, and let me give you a little hint. These will have to be denoted: friction and a force of some sort. So let's just kind of quickly review. Memorize these in this order: weight, normal force, and remember, normal force is only when you're on a solid surface. So if you don't see the surface, don't assume. Tension is if you see a spring, string, rope, whatever, and if there's two or more, be specific. Now these last two, your friction force and your force, these will be denoted somewhere in the reading or with the diagram. So let's do some examples. And remember, what we're going to do, I want to tell you, we're going to draw arrows. So please draw an arrow, not just a line. Okay, resolve all forces. So let's look at basically our flow chart. The first thing is weight. Weight will always go down. So what we're going to do, we've kind of assumed this is a point. We're going to draw an arrow going straight down, and you do need to label it. Weight. Your instructor might have you do somewhere else, but I like to have just, let's write them out, because sometimes your writing can get a little sloppy, and the reader or your instructor might think you're writing something else. Okay, let's see, the next one is normal. Okay, we're on a surface, so the normal is perpendicular to the surface. Remember, perpendicular is at right angles, and we're going to write normal force. Okay. Let's see, no rope, string, so the tension is out, and I didn't say anything on this about friction or pulling. Okay, so there's your two forces acting on example 1. Example 2, so let's say resolve all forces. Okay, weight. Weight will be on, you notice 99.9. In other words, everything has weight. Weight will always go downward. Okay, we're on a surface. Okay, there's normal force. Okay, let's see, and we are pulled to the right with a rope. Okay, so the rope, so what we're going to do is draw an arrow along the rope, away from your object, and this will be tension. Now, if I had two or more ropes or a string and a spring, I would label it, but since it's just a rope, we're going to use just say tension and no friction or anything. Okay, let's see, we have a box on an inclined plane and it says friction is included. So let's look at our flow chart. The first thing is weight. Now weight is not this way. Weight will always be straight down. Okay, remember it's always downward towards the bottom of the page. Okay, the next one, we're on a surface, so it has normal force. Now, normal force is not always upward like we had in the first two. It is perpendicular to the surface. Okay. And then, let's see, there's no rope or spring. Okay, the tension is out, so the next one is friction. Now you notice it said friction is included, so remember friction keeps it from moving downward, so friction is that way. So we're going to say friction force. Okay, nothing else. Okay, let's look at the other one. Okay, we're going to look at the smiley face, which is the ball. Okay, remember, everything has weight. So we're going to put weight here. Remember, and we're not going to look at the person. We're just looking at the ball. Okay, let's see, we're on okay, next one, surface. Are we on a surface here? Yes, we're going to call this, it's on a hand. So we have normal force. No surface here. We are on a surface here. There's normal force. Okay. Let's see, anything else? Okay, are we on a spring? Do we see a spring, string, anything? Nope, we're good. And nothing about the friction or air resistance, so there it is. That would be worth a few points. Okay, let's look at our example number 5. Okay, we have a pendulum. So we have two, and looking at one is going one way, the other is the other way. But remember, the first thing you will write in any free body diagram is weight. It will always, and we know what always means, will go downward. Okay? Now let's see, we're on a surface. Well, we can say, well, that's a surface, but remember, free body diagrams, you're looking at the object itself, nothing else. Okay, tension, yes, we have a pendulum, so we're going to go up the string and label it with tension. And there it is. Free body diagrams are very easy to do. Just remember your 5 things you're going to look for. You're going to look for weight, normal force, tension, friction, and just any other type of forces that's acting on the object. Remember, weight is always downward. It can't go up. Normal force is perpendicular to your surface if you have the surface. So you notice we had a surface here, that normal force. This one, right here, we weren't on a surface. So there's no normal force. Okay, the next one was tension, and you notice anytime you see spring, string, or anything to that effect, you're going to have tension. If there's more than one type of tension, label it. And then you have your friction force, and we didn't have the other force, but you'll see those in your reading. But those two will be given in your reading. There are examples on here, plenty of them to work. Remember, if you do have any questions, feel free to contact me.